Do you remember the excitement of getting your first computer? I still do. And along with our first computer, my parents bought a German-made WaveMaster MX1 audio system. It sounded great, the bass was very nice. The volume was controlled with a wheel that you would spin around. Spinning it all the way to one direction would turn the system off, and the other would be max volume. After 10 years of use, the controller was overused to the point where you would need to struggle for a few minutes to even get the system on. You would try to turn the wheel to get it in the right position, but it just seemed to be slipping around inside. One day, I walked into the room, and I found something unusual with the controller. You have 3 seconds to guess what it was. Wrong. I came into the room and found scissors smashed inside it, and I don't blame whoever did it. Since no one planned on fixing it anyway, I took the system and had it for 7 years now. And I didn't fix it either. It has been sitting around in a box for all these years, but it will change today. Or will it? This sound system is the only thing that I preserved from the original PC times, and the PC itself is now long gone. So I wanted to make things right. I want to make the system work again. Originally I had a genius idea. I messaged the maker of the system, WaveMaster, and was like, "Hey, I have this old model of your system. Can you help me with this controller issue?" The response I got was that the system is already 17 years old. More than anything, the response reminded me of my own age. This also meant that the WaveMaster discontinued the system a long time ago, with any replacement parts. WaveMaster was nice enough to send me a schematic to the entire system, pointing out that the top left was the volume controller. Their nice attitude was a bit surprising to me after watching some Louis Rossmann videos, and guided by his spirit, I looked at the schematic that had mere 5 components, and I thought, I could make this myself. Will I be able to revive it? There is only one way to find out, and I just hope this does not become a DIY. So, where do we start? I learned some physics in high school, but they only teach theoretical physics. But knowing the basic theory is better than nothing, right? My hope was to decipher the schematic with the help of the internet. And there was a tiny issue with the schematic. I think this was from the era where schematics were still drawn by hand, and just later had been scanned with a scanner. This led to the text being mostly unreadable, so I knew what each component was, but just couldn't make out what the text was saying. Let's go over this controller schematic. At the right we have a stereo connector that has 3 wires, usually for left audio, right audio and ground. In this case it transfers electricity and not signals, but we will get to that. There is a resistor at the bottom, a potentiometer at the left, a switch and a light diode. I will try to explain what each of them do as I go with the project. Just have in mind that I might be wrong since I'm no electrician. If you have any tips or spot any mistakes, let me know in the comments. It was shopping time. I bought a soldering iron, some solder, a multimeter, resistors, potentiometers, LEDs, cables and other necessities. It cost me around 80 euros to buy everything, but of course many of these things could last for years of use, and maybe I could use it for other projects if people enjoy content like this. On a high level, the signal in the system likely goes in some sort of a path from the input device to the speakers, and a part of that path was the amplifier, which was likely managed by the controller and allowed it to control the volume, I think. I thought that because there was nothing in the controller to my knowledge that would increase the current. Instead, my theory was that it worked by reducing the current given to the amplifier by increasing the resistance. I wanted to confirm that, for science. I took the stereo cable and soldered all 3 wires together. And what do you know, it actually played at 100% volume all the time. Into the control goes this little thing we made. It's not even like properly insulated, but I don't think it matters for now. Good, there's no static noise. Of course it's not properly in contact, I think, but we'll see. Oh my god, it's working. This could work as a solution, except for the fact that if I accidentally left the volume at 100% on my computer and switched the audio from headphones to the system, I would wake up the entire neighborhood. At this point, I didn't exactly know how the components impacted the volume. Overall, this felt exactly like programming a new thing for me. I needed to connect these 3 wires to the components as shown in the schematic, so that I can reduce the volume, since we already established that by default, the system is running at 100%. When I put it like that, it doesn't sound too bad. We can first make an observation on how the volume would get reduced. If the volume is defined by how much current is passing through the cable, then we want to be able to make it weaker. In electronics, current is limited by using resistors. Simply said, they resist the flow of a current and make it harder for the current to flow. A potentiometer, on the other hand, is a resistor that can change its resistance and is the key component here. The wheel in the original controller was attached to a potentiometer that would reduce or increase the current when the wheel was turned. We need to do the same. I draw a beautiful schematic of my own so I could look it up while soldering. I marked which cable I thought was which and went to town with a new iron, trying to recreate the setup. I tried different configurations and none of them seemed to work. This is this. Hopefully. Of course we don't have like any sort of switch, but I don't think I burned anything though, so let's just try connecting it to the let's just try connecting it to the system and see what it does. One time I got it to kinda work, and the volume would almost instantly jump to 100% by turning the potentiometer by just a tiny bit. And things were going not great. At this point, my lizard brain actually remembered that I bought a multimeter so I could detect which wire is which. The way this works is that you put one probe on one wire and the other probe on another. You usually would not do this by hugging the wire with your bare hands, but I checked before filming that the voltage here is very low, and I could probably put my tongue on the cables if I wanted. I am going to leave that stuff to Electro Boom though.
1, 2, 3, 4.
Anyway, between the ground wire and the input wire, the voltage is 11 volts. This allowed me to determine that the red wire is ground, which I previously thought was the black wire. We're getting somewhere. Another important part of the schematic is the diode. In this case, it also emits light, so it's an LED. Diode is a component that allows the current to flow only one way. I have no idea how this works in the actual controller, and here I just incorporated the tester's mindset. I checked every single combination and orientation of the diode. This method was a good idea because in the end I managed to find what I think to be the right combination for the components. Perfect. So, I can shut it off. Completely shut off. It plays. The wires won't be naked in the air, so it was time for the second phase of the project. I needed to put this wire mess into a device similar to the one I previously had, or at least try to. I recently bought a 3D printer, not really related to this project, but this was a good time to actually put it to something useful. It was my first time making my own models and I found it a bit hard. I initially started modeling with FreeCAD, but my experience was terrible. I just could not grasp how to do what I want. I later tried using free SketchUp in the browser, and it felt to be much more intuitive to use. After spending some time, I managed to pull off something that I thought resembled the original concept using SketchUp. I 3D printed a case that would store the electronics, a gear that would mount on top of the potentiometer, and a lid to cover the bottom of the case. The wheel would stick outside the case and be spun around to control the volume. It took me a couple of days to print, but the plan was going well. I was getting anxious to put everything together, but this is where things started spiraling out of control in the electronics department. You see, I decided that I wanted a longer cable so that I could place the controller on my table. Reasonable. I took a longer cable. The 3 wires inside were different colors, but that was not the issue, and I solved this pretty quickly with the multimeter. The issue was the static noise that appeared. I tried soldering, resoldering, and even switching the cables despite knowing they were in the right position. It didn't help. So right now it's working. It's working. But there's a huge static noise. I had the wires correctly and noticed that sometimes the static would reduce based on where I stand in the room, and I didn't understand why this was happening. I went back to the old cable. No static. And then I started to Google and ask ChatGPT. It was the cable, or rather a lack of a proper one. It was supposed to be a shielded cable, specifically aimed to shield from electromagnetic interference. This was probably something similar to how having phone near the headphones causes that weird beeping noise. If the length of the cable is short, it does not pick up much interference, but with large length this becomes a very apparent problem. Hopefully someone with more knowledge will be able to comment on this. Feeling tired of this problem, I made the choice to just keep the length of the cable short. I was not sure where to find a cable made specifically for this, but also if I wanted, I felt that I could always resolder the circuit because I felt confident now. Some time ago, I put out a poll asking, "What do you like the most?" and labeled it as for a secret non-programming video, which was this video, and I gave 3 options: space, dinosaurs, and modern art. The poll concluded with space being 70% of the votes, and it was my responsibility to give what was asked. I decided to draw a black hole on the front of the controller. It is no coincidence that it was printed with white PLA, since I did not know what it would look like in the end. I went over it multiple times with black gouache to make it completely black, and then tried to draw a black hole. It did not come out as good as I wanted, but oh well. I also tried drawing Mars on the side of the case, and it became clear that I should have sanded the case with sandpaper prior to painting, so the gouache would stick properly, because at the end of drawing, the side was looking like this. Seeing as multiple things went wrong already, I just decided to go with my mistakes. I applied a few coats of varnish, so the paint does not crumble away completely and becomes more permanent. Doing all of this, I felt like an elementary school student. It was finally time for the last phase, putting everything together. The quality of this thing will speak for itself. I had to resolder everything one last time because the cable needed to go through the hole I made in the model. For holding everything in place, I decided to use hot glue. I heated the gun, and first was the potentiometer wheel. The glue almost instantly solidified while the wheel was still a bit sideways, so it's now wonky. A perfect start. The funniest part was gluing the potentiometer. The gap between the case and where the potentiometer was meant to sit was so large that I ended up pouring a ton of hot glue and had to hold it in place for almost 10 minutes for the glue to cool down and harden. I had plenty of time to think about this project. After that, I glued the LED, the cable, put on the lid and put small dabs of glue on 2 corners in case I need to open it up again. And we are done. The final creation ended up looking like this. The moment of truth? Will the crooked controller work? Oh my god. Could be better, could be worse. It's grinding against the case. Not as important as it actually working though.
Hello, it's me, Sick Gains. I just finished editing the video, still a bit sick, but hopefully you don't mind. It took me quite a while to make this, and I likely messed a lot of things in my explanations, but hopefully it was not too far off from the truth. The controller itself was the perfect embodiment of imperfection. Wrong cables, falling paint, and a crooked wheel sounds exactly like my type of project. I really enjoyed making something physical and will likely come up with something for the future videos. I would love to visit robotics and maybe even some other topics to not get burned out on my coding series. By the time I finished editing, a new year almost came, so for those celebrating, happy upcoming new year! May you become better than you were the previous year. A sincere thank you for those still watching till the very end. If you haven't already, consider dropping a like and subscribing if you wish to see more like this. Hopefully you learned something new. See ya!